Welcome to Kenton Teaches. Enjoy the video.
You start by measuring, run time it and see profile to find the real hotspots, not the obvious suspects. Once you have a baseline, focus on the functions that dominate CPU or I/O. This prevents wasted effort. Make small reproducible inputs and unit tests so you can change code safely and confirm improvements. As you work, log before and after metrics and keep commits focused, because incremental wins avoid regressions and let you iterate quickly. You now replace costly approaches with better algorithms and data structures. Switching n² code to n-log-n can be transformative. Next, prefer Python built-ins, comprehensions, and generators to reduce overhead and memory use. They're implemented in C and run faster. Once done, consider concurrency. Use multiprocessing for CPU-bound tasks and Asyncio or threads for I/O-bound flows. Make sure to profile again, because micro-optimizations you finalize by adding targeted caching or memoization where repeated computations occur. That reduces work without huge redesigns. Then run benchmarks and CI tests to measure latency, throughput, and correctness. Compare to your baseline. If things go wrong, bisect commits to isolate the regression and revert the minimal change to restore behavior, then reapply improvements more carefully. Finally, document the decision, why this approach improved performance and what trade-offs you accepted.
Thanks for watching. Please subscribe if this video was helpful.